Write out the electron configurations and orbital diagrams for the following elements: carbon, silicon, chlorine, and calcium. So first off, when you're doing these either electron configurations or orbital diagrams, you should be familiar with this diagram here and how to draw it, because this will help you with the order of how they go. They don't just go S, P, D, F, 1, 2, 3, 4. They follow a different pattern. So what you do is you write the 1 through 7 S's first, one below the other. And then you start with the two P's, since the P suborbitals start at the second principal energy level. And you go down to 7 as well for them. You start the D's at the third principal energy level, and you only need to go down to 6. It's not that 7 doesn't exist. However, we don't have enough elements on the periodic table that we know of yet to need a 7p suborbital. And same thing with the F's. You start them at 4, since the fourth principal energy level is where the F suborbitals start. And you really only need a couple of those. Now, you take an arrow, and you sort of go diagonally down through the diagram. So you start with 1s, and then you move to 2s, and then 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and then 5f, 6d, 7p, and that covers the entire periodic table. So as you're filling in the next energy level, you just follow the arrows. When you get to the end of one arrow, you start at the beginning of the next arrow. So let's do carbon first. What you need to know when you're doing these is how many electrons do these elements have. And so we look on the periodic table and we see that carbon has 6 electrons. So we start filling up the energy levels from there. So we start with the 1s, and it holds 2 electrons. That's what the exponent there means. It's not really a mathematical exponent. It just means that there's 2 electrons in that orbital. Then you move to the 2s, and it holds 2, so that's a total of 4. And then we're on to the p's, which can hold up to 6, but since we only need 2 more to add up to 6 electrons, we are done. To draw the orbital diagrams, or box diagrams, you draw a box underneath each of these orbitals, which represents their orientations. So since S's only have one orientation, you only draw one box, and since P's have 3 orientations, you draw 3 boxes. And then you fill in the electrons like so: 1 up, 1 down, 1 up, 1 down. And the P's, you fill in all 3 first before you start putting a second one in. So it's sort of like seats on the bus. You don't sit next to someone if you don't have to. So there's 3 seats available, and so 2 people, each one will take their own. If there's a third, it would fill in that third box, and if there's a fourth, it would then be an opposite electron in the first box again. So let's look at silicon. Silicon, you'll notice on the periodic table, falls directly below carbon, so they're in the same group, just one period higher up. And we'll notice a similarity here. So for silicon, there are 14 electrons, and so we'll start with 1s, it holds 2, 2s holds 2, 2p holds up to 6, and so that gives us 10. 3s comes next, that's 2 more, so that's 12. And then we go to the 3p, and it only needs 2 because silicon only has 14 electrons. And we draw the boxes underneath for the box diagram. Technically, an electron configuration uses the exponents, and an orbital diagram does not, but I'm sort of combining the two here for the sake of space. Normally, you just write the 1s without the exponent and then write the box. So they're sort of the 2 different ways of showing the same information. So we fill this up: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So note the similarity in their configurations. The only difference is carbon's last electrons are in the 2p orbital, and silicon's last 2 are in the 3p orbital. So very similar, and they are in similar groups, or they're in the same group. Chlorine has 17 electrons, so this will be 3 more than silicon. 2, 2, 6, 2, which is a total of 12, And so we need 5 more, and that gives us 17. And the box diagrams will look very similar. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And note how I filled those up. All 3, 1 in each box, and then the next 2 go in to double up on those boxes. Lastly, we have calcium, which is our biggest element here on this example, and there's 20 electrons. So we go 1s2, 2s2, 2p6, that gives us 10. 3s2 is 12. 3p6 is 18. And what follows 3p is 4s, and there's 2 in there. Box diagram, no different. 3 boxes below P's. If there was D or F, you would need 5 boxes under D's because they have 5 orientations. And if there's any F's, if we had a big enough element to require F's, we would need 7 boxes underneath because they can hold up to 14 electrons with 7 orientations. Note how there's no difference in these early orbitals here. As if they're full, and they all look the same for each element. It's just that when you get out further, that you need more electrons. And that's it.